Read example 3.2, which can be found on page 16 of your lecture notes, on your own. Refer to example 3.3 in your lecture notes. The table, as shown on the screen, shows 4 sets of bivariate data. Part 1. Find the values of the product moment correlation coefficient for each set of data. Part 2. Sketch the scatter diagrams for each of the sets of the bivariate data. Part 3. Using your sketches in Part 2, comment on the strengths of the linear relationships between the two variables for each set of data, and compare between the effectiveness of using the R values, and that of using the scatter diagrams to determine the strength of the linear relationship for a set of bivariate data. For Part 1, one can verify that the values of the product moment correlation coefficient for each set of data is equal to 0.816, correct to 3 significant figures. For Part 2, the scatter diagrams are as shown on the screen. Notice that despite sharing the same R values, the scatter diagrams demonstrate very different relationships among all 4 sets of data. For Part 3, based on the sketches in Part 2, the third set of data demonstrates a strongest linear relationship between the two variables, except for the presence of an outlier. Since all the R values are the same, we cannot tell which dataset has the strongest linear relationship based on the R values alone. We need to look at the scatter diagram to help us decide. In other words, the R value alone is sometimes not enough to fully illustrate the strength of the linear relationship between the two variables. The scatter diagrams give a clearer and more complete picture in this aspect. Refer to example 3.4 in your lecture notes. Part 1. Sketch an example of a scatter diagram indicating the following. A linear product moment coefficient close to 0, but there is an obvious relation between the variables. Part 2. If the estimated product moment correlation coefficient has a value close to +1 or to -1, explain why this need not imply that there is a linear relationship between the variables. For Part 1, a possible sketch satisfying the question requirement is as shown on the screen. For this particular sketch, note that R is close to 0, but there exists an obvious relationship, possibly a quadratic one, between the variables. For Part 2, R is close to 1 or to -1 indicates a linear relationship for values within the sample range. However, it does not tell us the relation for data values outside this range. For example, R may be calculated using the last 4 pairs of data for the above scatter diagram, which gives almost a linear relation,